So this section is all about dividing polynomials, and we've got 3 different methods that we're going to look at, starting with kind of the most simple one, I guess. In this one, in example 1, dividing a polynomial by a monomial. Just to clarify what those words mean, polynomial, remember poly means many, and so this is a polynomial. It's got multiple terms. Dividing it by a monomial would be dividing it by one term. And so what we're doing with these is we're taking that whole polynomial on the left, dividing it by the term on the right. What we do with that is you take each one of these terms in the polynomial and you divide them each by the monomial. So let's write down some work for that. So take the 20 c to the 4th d squared f, divide that term by 4 c d f. Then the next one is, we do minus because this is negative. 16 c d f squared divided by 4 c d f, and then plus 4 CDF divided by 4 CDF. So we're dividing each thing, term by term, by that monomial on the right-hand side. And so what we do is we basically do what we were doing in the previous lesson. You reduce down the numbers, reduce down each of the variables, and then simplify everything up. So here for the numbers, we've got 20 divided by 4, which we know is 5. C to the 4th divided by c to the 1st, technically. So you subtract those powers. Power of 4 minus the power of 1 leaves us with 3 copies of c. D squared divided by d, subtract 2 minus 1, and now we just have d to the 1st technically, and then f over f, those cancel out, so we don't have any f's left with this one. Minus, next one, 16 divided by 4 is 4, c divided by c, they cancel, d divided by d, they cancel, f squared divided by f, we subtract the 2 minus 1, and our new power is 1, so just one copy of f. Last one, plus 4 over 4 is 1, c's cancel, d's cancel, and f's cancel, so it's really just 1. Alright, so this is our final answer. It's a simplified polynomial. Okay, we're going to do the same thing with this one. First of all, this 3xy to the negative first power, if something is written to the negative first power like that, remember what it really means is that you write it down in the denominator. So we're taking that negative first power and we're flipping this term down into the denominator. Alright, so now let's do the same thing where we divide each expression. So we're going to divide this expression by the 3xy first. So 18 divided by 3 is 6. X squared divided by x, subtract the powers, 2 minus 1, leaves us with just x to the first. And then the y's cancel. Y divided by y is just 1. Then plus, now we divide this term by the 3xy. So 27 divided by 3 is 9. X cubed divided by x, we subtract 3 minus 1. Our new power is 2. Y squared divided by y, subtract 2 minus 1, and our new power is just 1, y to the first. And there's no z at all down here, so we just leave this z that this one had. And that is our reduced polynomial. Okay, so that's kind of the simple stuff, dividing a polynomial by a monomial. And so the next thing we're going to move into is polynomial long division. So if you guys remember long division from, like, I don't know, 6th grade, we're going to kind of run through that, do this process that's really similar to numerical long division. So I'm going to run through this problem, and it will kind of remind us of how these things work. So 6,043 divided by 18. So let's walk through this process. So the thing that you're dividing, you put it underneath the quotient and then put the 18 on the outside. So what you do is you go kind of term by term and figure out how many times 18 goes into each piece here. So how many times does 18 go into 6? Well, it doesn't, so we move on to the next digit. How many times does 18 go into 60? So we've got 18 times 2 is 36, times 3 would be 54, so that would be it. So 18 times 3 is 54. So then what you do is you multiply 3 times the 18, we get 54, and then we subtract 54. Okay, so 60 minus 54 leaves us with 6. The next step is to bring down the next term, bring down the 4, and then we repeat the process. So we ask ourselves, how many times does 18 go into 64? Well, that would still be 3. And so same thing again, we take this 3, multiply it by 18, we get 54, and we subtract 54. So 64 minus 54 leaves us with 10. Bring down the next term, 103. Okay, so we want to know how many times does 18 go into 103? So we've got 18 times 2 is 36, times 3 is 54, times 4 is 72, times 5 is 90. Okay, so that would be 5 times. And then you multiply 18 times 5, and we get 90. So we subtract that, and our remainder is 13. There are no new terms to bring down. And so here's what we do. We write 335, which is what we had along the top, and then we take the remainder, 13, and then we write it over the divisor of 18. And so that is what we get for our final answer. So we're going to use these steps in order to do polynomial long division. So let me walk you through those steps again. So we estimate how many times does 18 go into this first thing. We write it above, multiply these two things together and subtract, bring down the next term, and repeat the process. That is exactly what we're going to do with polynomial long division. So let's write this out. So we're taking x squared plus 7x minus 30, and we are dividing it by x minus 3. So the only thing that's slightly different with polynomial long division is we're really only using the x to kind of divide in. So we want to know how many times does x go into x squared. So basically what we need to ask ourselves is, what do I multiply x by in order to get x squared? Well, x times x gives me x squared, so I put an x up here. And then same thing we did up above. I multiply the x times my divisor here, and what I get is x squared minus 3x. And so I subtract that quantity, x squared minus 3x. In this step, you need to be super, super, super careful with parentheses, because you'll be good at subtracting this term, then without parentheses, you'll forget to subtract this term. So we subtract, the x squareds cancel. Then I have 7x minus a negative, see why we need to be careful with parentheses, minus a negative 3x, so we get 10x. Then just like we did up here, we bring down the next term, so we bring down the minus 30. And then we look right here, how many times does x go into 10x? Or in other words, what multiplies by x to give us 10x? And that would be a positive 10. So I put a plus 10 right here, and then I do the same thing. I take the positive 10, multiply it by this expression, and subtract. So I set up my parentheses. So 10 times x is 10x, and then 10 times negative 3 is a negative 30. So I'm going to very carefully subtract. So 10x minus 10x, that cancels. And then negative 30 minus negative 30, that also cancels. So my remainder is 0. So with a remainder of 0, I just have this thing right here. So when I divide, I get just an x plus 10. So that is my answer. All right, let's do another one of these. So I set up the same way. So I take the x squared minus 13x plus 12. I'm going to divide that by x minus 1. So just like I did up above, I'm really only looking at this first term when I try to divide. So we ask ourselves, how many times does x go into x squared? Or in other words, what do I have to multiply x by in order to get x squared? Well, x times x gives me x squared. So I know I'm going to subtract, so I set up my parentheses, because if we don't set up our parentheses, we're going to mess up the signs. So we we multiply x by x minus 1, and we subtract. So x times x is x squared. X times negative 1 is negative x. So we carefully subtract negative 13 minus negative x, so plus x, and we get a negative 12x. Bring down the next term. So now we're looking at this term right here, and we ask ourselves, how many times does x go into negative 12x? Or in other words, what do I multiply x by to get negative 12x? And that would be a negative 12. Okay, so I know I'm going to multiply and subtract. So distribute the negative 12 to this expression right here. Negative 12 times x gives me a negative 12x. And then negative 12 times negative 1 gives me a positive 12. So again, both of these terms are going to cancel here when I subtract. So my remainder, once again, is 0, which means my answer is just the stuff up here. I don't have to write the remainder part. Okay, so we got a couple of examples there. These were nice, neat ones where we got just an x plus 10, just an x minus 12. We didn't have any remainders or anything like that. Okay, so let's do one more long division. So this one, again, the 2 minus a to the negative first. Remember what that really means is you're dividing by that term. So we are taking this and we are dividing by this term, 2 minus a. Okay, so same setup as before. We're going to take the a squared minus 5a plus 3, and we're going to divide it by that expression, 2 minus a. Now here, the negative a is really our leading term. So we always want it to be the a or the x or whatever that we're dividing by. So we divide this out. How many times does negative a go into a squared? Or in other words, what do I have to multiply negative a by in order to get a squared? And that would be a negative a. So I set up, multiply, and subtract. So negative a times 2 is a negative 2a. I'm actually going to line it up right here under the appropriate like term. And then negative a times negative a is a positive a squared. So subtract a squared minus a squared cancels. Negative 5a plus 2a gives me a negative 3a, and then plus 3. So I'm going to do this again. How many times does negative a go into negative 3a? Well, negative a times 3 would give me a negative 3a. So I put a plus 3 right here. Set up my subtraction. So 3 times 2 gives me 6, so I line it up under the constant. 3 times negative a gives me negative 3a. Okay, negative 3a minus a negative 3a, they cancel. 3 minus 6 gives me a negative 3. So that's my remainder. So here's how I write this. I write negative a plus 3. That's the part that I pull from the top here. And then my remainder is negative, so I do minus 3 over my divisor of 2 minus a. All right, so just to recap that. Here's the stuff that I have from up top, and then I take my remainder of negative 3, and I write it over the divisor right here. So that's your final answer. This is the first one we saw with a remainder, so we write the answer a little bit differently. Okay, so that's polynomial long division. The other way to do the exact same thing is to do something called synthetic division. So I'm going to write down a step-by-step, and as we're writing down the step-by-step, we're going to go through this first example for A. Okay, so step 1. What we do is we write the coefficients of the dividend in descending order. So you have to write the coefficients in the proper order, meaning the coefficient on x to the third goes first, then the coefficient on x squared, then the coefficient on x, etc. Write the constant r in the box. All right? Okay, so let's write down what we've got so far. So write the coefficients in descending degree order. So the x cubed is first, so we write 2. Then we write this positive 3. Then negative 4. Then 15. Okay, and then on the left-hand side, we make a little box. There's our little box. And we write the opposite of this number. So if we were to solve for this, we'd write what we get. So if we were to solve for this, we'd get negative 3. So we put a little negative 3 in the box. All right, so that's how we set that up. Okay, and then still kind of part of the first step is that we bring the first coefficient down. Okay, so we bring this first coefficient down, 2. Okay, so this process is going to seem a little bit strange the first time around, and then all of a sudden it's going to click and you're going to be like, oh, this is so wonderfully easy. I want to do this all the time. Okay, number 2, multiply the first coefficient by r. And write the product under the second coefficient. Okay, so what that means, I multiply these two together. So multiply the first coefficient by r and write the product under the second coefficient. So 2 times negative 3 is negative 6, so I write that right here. Okay, that was my next step. Add the product and the second coefficient. Okay, so I add these two together. So 3 and negative 6 gives me a negative 3. That's my third step. Okay, and then 4, I repeat steps 2 and 3 until you get to the last column. So these are the new coefficients. There we go. Okay, so now repeat steps 2 and 3. So step 2 and 3 said now this one. So what I did is I brought the 2 down, I multiplied these two together, I get -6. Add these together, I get -3. My next step is to multiply these two together. So -3 times -3 gives me +9. Then I add these two together. -4 plus 9 gives me 5. Then I multiply these two together. I get -15. And then I add these two together and I get 0. So now I'm done. So these are the coefficients, the new coefficients. And the way this works is that the first term is going to be 1 less than the degree of the dividend. Because when I divide by an x cubed divided by an x, and I'm left with x squared. So I put a 2 in front of an x squared, then a -3 in front of an x. My constant is this +5, and then my remainder is 0, so I don't need to write that. So this is my answer right here. Okay, so let's do this again. So I take these coefficients, write them in descending order. So I get 4 in front of the a to the 4th. I don't have an x cubed. This part's very important. Or I don't have an a cubed. So you write a 0 for whatever goes in front of the a cubed. And there's a +2 in front of the a squared. -4 in front of the a, and my constant is a 12. Okay, then in this little box, I'm going to put the opposite of this number. So I put a -2. Then I start this process all over again. So I bring down my first term, I get 4. Multiply these two together. -2 times 4 gives me a -8. Add these two together, I get -8. Multiply by this, -2 times -8 gives me a +16. Add these two together, and I get 18. Multiply that by a -2, and I get -36. Add these two together, and I get a -40. Multiply these two together, -2 times -40 is a +80. And finally add these two together, and I get 92. Okay, so put these all into a polynomial. So the 4 goes in front of an a cubed. I dropped this down by 1. So 4a cubed, then -8 goes in front of an a squared, 18 goes in front of an a, -40 is the constant, and then the remainder is 92. So remember from the previous page what I do with the remainder is I put a +92 over the divisor, which is a plus 2. Okay, so that's my answer. Don't forget about the remainder here. Okay, let's do one more of these. I have a 6 in front of the b to the 4th. I have a -8 in front of the b cubed. I don't have a b squared, so I write a 0. I have a 12 in front of the b, and a -14 is my constant. I put the opposite of this in a box, so I put a +2 in a box. First step is I bring down that first coefficient. Multiply the coefficient by 2, I get 12. Add this column together, -8 and +12 gives me 4. Multiply 4 by 2, that gives me 8. Add the 0 and 8, and I get 8. Multiply that by 2, gives me 16. Add these two together, I get 28. Multiply 28 by 2, I get 56. Add these two together, and I get 42. Okay, so those are all my coefficients. I'm going to put them together in a new polynomial. So drop this power down by 1, I get b cubed. So 6 b cubed plus 4 b squared plus 8b plus 28 is my constant, and then my remainder is 42. So 42 over the divisor, which is b minus 2. So that is your new polynomial. Okay, so really important thing here. In order to use the synthetic division, the form it must be of the form x minus r. So x plus 3, a plus 2, b minus 2. You can't have anything in front of the x, a, b, whatever. So if the coefficient is not just 1, you can rewrite the division expression. So let's walk through that process. There's just a couple more examples on the back here. Okay, so if you look at these ones, example 5, you've got a 2x plus 1, you have a 4y minus 1, and so we do just a slight little tweak to rewrite this, and what we do with that thing is we divide by whatever that coefficient is. So if you've got something in front of like the 3x squared or the 1, we divide literally every single thing by that constant. Okay, so since this is a 2, we're going to divide absolutely everything by a 2. Okay, and then let's rewrite what we get for that. So 8x to the 4th becomes 4x to the 4th minus 2x squared. Plus, when I divide this by 2, I end up with a 1/2 x. And then 4 divided by 2 is 2. Okay, so that's my new first one. And then divide this by 2, 2x divided by 2 is x, and then 1 divided by 2 is 1/2. So that's my new division problem. All right, so now this is just a plain old x, so I'm good to go. I can set everything up. So I set up my coefficients. So 4x to the 4th. There is no x cubed, so I put a 0. Negative 2x squared, 1/2 x, and then 2 is our constant. So we take the opposite of this, we put it in a box. So negative 1/2. First step, these are the same steps we have in the front. We bring this first term down. Multiply this by this, so 4 times a negative 1/2. We know it's going to be negative. And then half of 4 is 2. Okay, so now bring that down. 0 and negative 2 gives me negative 2. Negative 2 times negative 1/2. They're both negative, so I know it's positive. Half of 2 is 1. Negative 2 and a negative 1 gives me negative 1. Then I multiply negative 1 by negative 1/2, and I get positive 1/2. When I add these together, 1/2 and 1/2 gives me 1. Then finally I multiply these together. 1/2 times negative 1/2 gives me negative 1/2. Then when I add these together, I have 2 minus 1/2, so I get 1.5 or 3/2. Okay, so that's where I'm at so far. So now let's rewrite everything. All right, so rewrite this as I have a 4x cubed minus 2x squared minus 1x plus 1, and then plus I write 3/2 over x plus 1/2. Okay, so now I do need to rearrange everything, so I'm going to kind of simplify this fraction up. So this thing on the end here, they both have 2's. I don't want the 2's to be there, the denominators, so I multiply this by 2 over 2. And then I can clean that fraction up a little bit. So let me rewrite that. So 4x cubed minus 2x squared minus x plus 1. That part hasn't changed. And this part right here, when I multiply everything by 2, 3/2 times 2, the 2's cancel, and I just have 3. And then over, when I re-multiply this by 2, I end up with this original thing here. 2 times x is 2x, and then 2 times 1/2 is 1. So this is my final answer. All right, so it's just a slight little tweak, and then the process is the same. All right, so we're going to do the same thing here. So this has a 4, so I'm going to divide every single piece here by a 4, and then rewrite it. So 8y to the 5th divided by 4 leaves me with 2y to the 5th, minus 2 divided by 4 is 1/2. 16 divided by 4 is 4. 4 divided by 4 is 1. So that's my original polynomial, divided by 4. And then divide this by, now divide these things by 4. 4y divided by 4 is just a y, which is exactly what I needed. And then minus 1/4. Okay, 1 divided by 4. So again, that's my kind of new rearranged version. So I'm going to set it up the same way. So I've got a 2 is my first coefficient, then a negative 1/2. I don't have a y cubed, so I write a 0. Then this is a negative 4. This is a positive 1. Oops, I guess I didn't need the plus. And then I put the opposite of this in a box, so a positive 1/4. Okay, so bring the first coefficient down. Multiply 2 by 1/4. 2 times a 4th is 2/4, or 1/2. Add these together. Negative 1/2, positive 1/2, I get 0. 0 times 1/4, of course, is 0. Add these together, I still get 0. Again, 0 times 1/4 gives me 0. Combine these up, negative 4 and 0, I get negative 4. Negative 4 times positive 1/4, I get a negative 1. And then when I add these two together, I get 0. Okay, so let's write our final answer here. So 2 is in front of a y to the 4th. because this is y to the fifth, so I drop it down 1 power. 0y cubed, 0y squared. So this would be a negative 4y. Whoops, I'm sorry, we missed something here. Okay, let's look back here. There's no y term either. So this is supposed to be a 0. And then this is a 1. Okay, so let's try this again. So from this step, 4 and 0 gives me negative 4. Negative 4 times 1/4 is negative 1. So 0 and negative 1 is negative 1. There we go. Negative 1 times 1/4 is a negative 1/4. So when I combine these up, 1 and a negative 1/4 is a positive 3/4. That looks better. Okay, so 0y cubed, 0y squared, negative 4y minus 1. And then I put 3/4 over y minus 1/4. So the last thing I'm going to do is just like what I did up above. I'm going to multiply this by 4 over 4 to get rid of those fractions. And I will rewrite my final answer. So 2y to the 4th minus 4y minus 1. And then plus, when I multiply this by 4, I just get 3 because the 4's cancel. And then I'm back to the original 4y minus 1. So there's my final polynomial, remainder and all. All right, all done.